Hello everyone. I'm going to talk about chapter 12. In this chapter, we are going to discuss about intermolecular forces. Intermolecular forces, or IMFs, they are forces that we are going to study for different types of molecules, liquid, solid, and gas. So in general, we are going to answer these two questions. Why the molecules are attracted by each other, and why do we have three states of matter in chemistry: solid, liquid, and gas. In physics, we may have more phases or states of matter, but in chemistry, we are going to classify them by these three different states: solid, liquid, and gases. For example, we are going to know why the solids are strong, why water is going to be in the liquid form, and oxygen and the air is going to be a gas. First, to define intermolecular forces, or IMF, we are going to have this basic definition. IMF is going to define as interaction between molecules. So whenever we say interaction between two molecules, we are going to talk about intermolecular forces, or IMF. In other words, we have molecules and we are going to find attraction between them. Another term we may see here is intramolecular forces. For intramolecular or intramolecular bond, we are going to talk about attraction between two atoms. So two different forces. Intermolecular forces, we call that IMF between two molecules, and intramolecular forces, in general, we call them bond, and it's going to happen between two atoms. So in our class, in this chapter, we are going to focus on intermolecular forces. When we say bonds, it means we are talking about intramolecular, and we are going to talk about covalent bond or ionic bond. So in this chapter, we prefer to call that intermolecular force, and we are talking about these forces in this chemistry class. Intermolecular forces are much weaker than intermolecular bonds. So let me change this terminology for this chapter. Intermolecular forces are much weaker than bonds, covalent bonds and ionic bonds. Again, when we say bonds, we are talking about atoms, attraction between two atoms, and whenever we say intermolecular forces, so I don't like this term, I prefer to call that intermolecular force, is going to happen between two molecules. We are going to see how to find out the strength of any intermolecular forces. As you see here, when we say if we have a stronger attraction between atoms or molecules in general, we are going to use too much energy or more energy to separate them. As long as we have a strong intermolecular forces, as long as we have strong bonds, we are going to use too much energy to separate them. So I'm going to back and say we focus on IMF, intermolecular forces. For our intermolecular forces, we are going to find a relationship between the observation that we have in chemistry labs and this concept. Boiling point or melting point, they are going to consider as one of the indicators we consider for intermolecular force. If we have higher boiling point, it means we need to use too much energy, we need to use higher temperature to separate the molecules. So it makes sense if we say if we have higher boiling point, it means we have a stronger IMF or a stronger intermolecular forces. So boiling point is going to represent the weakness or strength of our IMFs in the molecules. Higher boiling point, a stronger IMF. Lower boiling point means weaker IMF. In general, we are going to have four types of IMF. and I may ask you to memorize these terminology we are going to apply for our class. Dispersion or London forces, dipole forces, hydrogen bonds, and ion dipole. I'm going to talk about the meaning of each one in our class step by step by looking at the next slides. First, what is the dispersion force or London force? One scientist work on this force. We call that the London force or dispersion forces. This is a result of a temporary dipole. We are going to know what is the meaning of temporary dipole. Please look at the previous slide. If you remember that we have two types of compounds, two types of substances, polar substances, polar molecules, or nonpolar molecules. When we say polar molecules, it means we have a positive and negative pole. We have a new attraction between the atoms to attract the bonding electrons. For example, in HCl, chlorine attracts electron more than hydrogen because of higher electronegativity. When we have HCl, we have two non-identical atoms, so we call that polar molecules. Polar molecules, it has one pole positive, one pole negative. If we have nonpolar molecules like Cl2, two chlorine atoms join to each other, share their electrons, and they have the nonpolar molecules because both of them, they are identical, same elements or same atoms. If our compound or molecule has a polar bond or polar molecule we call that dipole. Dipole means we have two poles, positive pole, negative pole. If we have polar molecules, we may use these IMF forces, dipole force, between two positive, negative poles. Let's look here. Let me show you here. For polar molecules, positive, negative. Attraction force or IMF is going to be happen between two molecules. Negative pole of one, positive pole of another one. They are going to be attracted. We are going to call them dipole force. So dipole force always happen between polar molecules. If we have nonpolar molecule, at that time we don't have any poles, so we cannot imagine any attraction force because there is no pole for the nonpolar compounds. But we may say that when molecules move, when molecules collide each other, after collision, we have a little bit shifting between the sharing electrons based on the collision. Assume that we have a collision, so we have a reformed molecules. So at that time, we have for a moment, a temporary, we are going to have a little bit positive and negative for identical atoms. For example, Cl, they are here. So for one moment, when they collide each other, for one of the Cls we have positive, for another one we have negative. So this is a temporary dipole. This temporary dipole or weak dipole happen between any compounds they collide each other. So dispersion force is going to be based on the collision, based on the unequal sharing electrons between two identical atoms. And it's going to be temporary because after a moment, they are going to back. At that time that we have a temporary dipole, we have a positive and negative. At that time, we are going to make this IMF. We call that dispersion force or London force. So dispersion or London force is going to happen between only non-polar compounds because they are going to collide each other and they are going to make a temporary dipole. Right now, I'm going to talk about two IMF. Polar polar molecules, they are going to make dipole-dipole force, and nonpolar compounds, they are going to make dispersion force. If we are going to compare that, we say that dipole forces, they are stronger than dispersion forces because permanent polar compounds, they are going to make a stronger attraction force when we compare with the nonpolar compounds, they make the London force. Right now, I'm going to generalize the rule that we had. I said is going to dispersion forces, they are going to happen between any molecules when we have collision. So all molecules, they rotate, they move, and they have collision. So we are going to say dispersion forces is going to happen all the molecules, they are going to have dispersion forces, and dispersion forces are going to happen for any molecules because of the collision. So dispersion forces are going to happen for all of the molecules, and nonpolar molecules, they have only this type of IMF, we call it dispersion. If we have polar molecule like HCl, I may say HCl as a polar molecule has two types of IMF. Dipole force, because it has a permanent dipole, H and Cl, two different atoms, is going to have dipole forces, and also is going to have the dispersion because we have collision. So for any molecules that given to you, please write London or dispersion force. Then you are going to see, is it a polar molecule or not? If we have polar molecule, we call that dispersion force and dipole forces. If we have nonpolar, we are going to say only dispersion force. Another type of forces, intermolecular or IMF forces, they are a specific one of the dipole forces. If we have hydrogen bonded to one of these three most electronegative elements, nitrogen, hydrogen, and fluorine. Nitrogen, hydrogen, and fluorine. If we have bond of hydrogen with one of these three elements, we call that IMF hydrogen bond. So hydrogen bonds are special bonds in the chemistry when we are going to study intermolecular forces. Please look at this example. This is H2O. This ball and stick model represent H2O. Two hydrogen reported and represented by gray hair, white ones, and oxygen is this one. I have two different water molecules. Attraction between two different molecules, we call that IMF. Right now, hydrogen from this molecule is bonded by oxygen from this oxygen, from these other molecules. Hydrogen from this molecule, oxygen from another molecule. So this one, we call that hydrogen bond. So again, if we have hydrogen from one molecule bonded to oxygen from another molecule, so it means we have H and O. We call that hydrogen bond. Whenever we are going to report hydrogen bonds, we are going to use this dashed line. So hydrogen from one molecule, oxygen from another one. So this is the hydrogen. If we have solid line, we call that intramolecular force. We call that intramolecular bonds, or in general speaking, we call that bonds. And we call it covalent or ionic bonds. If we have dash bonds like this, it means we are going to represent intermolecular forces, IMF, and we call that hydrogen bond because between hydrogen and oxygen. The reason we have this attraction because hydrogens make positive and oxygen make negative pole here. So we call that hydrogen bond. So for water molecules, we have three types of IMF. Please remember that collision makes dispersion forces. Dipole-dipole force because of two different atoms, non-identical atoms. And the last one is hydrogen bond because we have hydrogen and oxygen. For water molecules, we have 4 hydrogen bonds. That is why we are going to have highest temperature, boiling point temperature for the water as a liquid in our daily life. Another type of IMFs, we call that ion dipole attraction. It happens whenever we have one ionic compound, ion, is going to dissolve in a polar compound like water. Ion dipole. So if we have two different compounds, two different substances, like NaCl in water. So for ion dipole, we have a mixture. In the mixture, solute is ionic compound like NaCl, and dipole is going to be a solvent like water. So NaCl, positive and negative ions, cation anions, they are going to make a new attraction. Positive ions, they are going to make attraction to oxygen because oxygen is negative pole of water. So this new attraction, we call it ion, and this one dipole because solvent is dipole. So we call it ion dipole attraction. Same scenario if we have negative charge ion, an ion is going to make attraction with hydrogen. Ion dipole is going to call for this type of attraction. And since we have ions, we have a pure positive or negative charge particles. So we call that ion dipole attraction is the strongest attraction for in our study. So ion dipole is going to make the strongest attraction if we are going to compare with the other forces. This table is going to represent dispersion you may find for all molecules because of the collisions, and only nonpolar compounds, they have this part. Polar compounds, we call their type of IMF dipole-dipole force because they are polar molecules. They have a permanent attraction between positive and negative pole. So polar molecules, they have two types of attraction. Not only dipole-dipole, but also based on the collision, they have dispersion as well. Hydrogen bonding, specific types of dipole-dipole. If hydrogen bonded to FON, fluorine, oxygen, nitrogen, at that time we call that we have hydrogen bonds. Hydrogen bonds, they are going to call dipole-dipole and dispersion as well. So 3 IMF types for the compounds they have hydrogen bonds. And ion dipole is going to be same. We are going to have dispersion because we have the collision between molecules. We have dipole-dipole between the solvents. We are going to have ion dipole because we are going to make a new attraction forces. As you see here, the strongest attraction force is going to call ion dipole. After that, hydrogen bonding, then dipole-dipole, and weakest one is dispersion. Whenever we are going to study IMF in the molecules, we prefer to work with the strongest one. So if we have hydrogen one, if we have hydrogen bonding, we don't care about dispersion or dipole-dipole. So this part, ion dipole, is going to happen in a mixture. We need to have two different compounds. So if we exclude that one in our study, hydrogen bond, the attraction force between two molecules is going to be a strongest bond in the attraction forces. That is why we call it by bond, but this is the hydrogen forces as well. If we are going to study of different compounds, we are going to remember that some compounds can be dissolved, some compounds cannot be dissolved in water. Or in other words, water can dissolve some compounds, not other compounds. Here, the examples I'm going to share with you, assume that you add oil to water. Oil cannot be mixed with water, and we are going to call that we have one type of mixture, heterogeneous mixture. We cannot make a solution, homogeneous mixture. So at that time, we remember that this rule, thumb rule in the chemistry, like dissolves likes. Polar compounds dissolves polar compounds. Nonpolar dissolves nonpolar. So whenever we say polar or nonpolar, we need to have a better understanding regarding them. If our compounds composed of only carbon and hydrogen, carbon and carbon, in our structural formula, you see only carbon and hydrogen, or carbon-carbon, we call that nonpolar molecules. If in your compound you have heteroatoms, like oxygen, like nitrogen, so we call that we have polar compounds. So it would be easy in case you have a compounds, if you have a compound, it composed of only carbon-carbon, only carbon hydrogen. We call that nonpolar. If we have oxygen, nitrogen, or any other heteroatoms like sulfur, fluorine, and so on, we call that polar compounds. We may use these two terms when we add to water, hydrophilic, hydrophobic. So we have hydrophilic groups, we have hydrophobic groups, polar or nonpolar. They are different terminology we may apply. And whenever we say one liquid can dissolve in water, it means we are going to make miscible liquids, like alcohol. Any alcohols have OH, so they can dissolve in water. So miscible liquids. You cannot identify where is the alcohol, where is the water. They can mix truly, and you cannot see the two different parts. But if you have oil and water, oil composed of only carbon and hydrogen, you can see oil and water. So at that part, we say oil and water are immiscible liquids, immiscible liquids. As you see here, for immiscible liquids, you see like this one, only carbon and hydrogen. Here we have water. So as long as you have carbon and hydrogen, you are going to make immiscible liquid. One thing I may ask you to pay attention when we are going to talk about the water, if we have oxygen in the formula, it means we most likely have polar compounds, and we are going to have hydrophilic groups, and we have miscible liquids. Some properties of liquids just used to represent strength of the IMF, intermolecular forces, viscosity, surface tension, vapor pressure, and boiling point. So first, I'm going to define viscosity. Viscosity, based on the basic definition, is resistance of a liquid to flow. As you see here, if it takes time or you see the resistance, you will say that we have greater attraction forces between the molecules. These larger intermolecular forces make larger viscosity. So this resistance is going to represent, is going to have a better observation to understand we have higher larger intermolecular forces or stronger intermolecular forces. Surface tension is another one. The attraction between molecules at the surface of the liquid. We call it surface tension. You can put a light object on the liquid and you can see the liquid can keep or hold that one because of attraction forces between two molecules, attraction forces between the molecules of the liquid. It makes it happen. So if we have a very small light light objects, we can put that one on the surface of the liquid, and it's going to represent we have larger intermolecular or stronger intermolecular forces. So surface tension is another one. And finally, if we are going to talk about vapor pressure, if you have a liquid and you convert that one to gas, liquid to gas, we call that vaporization. So the reverse, we call that condensation. If you remember that, if we put a liquid on the benzo burner, the liquid is going to absorb and gain heat. If liquid is quickly converted to the gas, it means the heat could break down attraction forces and make the gas molecules. It could easily vaporize the molecules. At that time, we are going to have many gas molecules. It means the vapor pressure is high. So if we have weak IMF, heat is going to break it down easily and we are going to have many gas molecules. In other words, if we have a strong IMF, we need to use more heat. You should put your liquid on the benzo burner, on the flame, on the heat for a long time. After a long time, we are going to see the molecules start to be heated, start to be converted to gas. At that time, we say we have a stronger IMF because it took time, because we need to use more energy to break down the intermolecular forces between the molecules. So vapor pressure is opposite by the other items we reviewed here. If we have higher vapor pressure, it means more vapor, more gas. It means we have weaker IMF. If I talk about boiling point, it means it takes time. We need to use too much energy to make higher temperature. So higher boiling point, it means a stronger IMF. So boiling point, viscosity, and surface tension, they are directly proportional to IMF. But vapor pressure is inversely proportional to IMF. If we are going to work with solids, not liquids, if we are going to work with solids, we are going to classify our solids as solids with the regular 3D arrangement like crystals or irregular 3D arrangement like amorphous solids. So let me give it you examples for each one. Solid like glass, solid like wood, solid like iron. If we say irregular shaped, irregular 3D arrangement, we are talking about like plastic one. For the plastic one, as you see here, you may change the shape of the plastic, but we call that solid. It's not liquid because we still have IMF between the molecules. So whenever we are going to work with the solids and compare their IMF, we are going to say something like this one. Crystalline solids can be classified by three different groups: atomic, ionic, molecular solids. Crystalline solids, it means we are going to see crystals. We are going to see a regular 3D arrangement. For atomic solids, we are going to have only one element like gold. Ionic solid, we have two different elements, metal, non-metal, or cation, anion. And for molecular solids, we are going to see only non-metals, only non-metals. So as you see here, the highest melting point belongs to crystalline solid here, and the lowest one belongs to molecules, molecular solid. Here, for atomic solids, we may have in this range, but in general, we may say, because of some exceptions that we have variable melting points for atomic solids. Probably they are going to be higher than the ionic or lower than the molecular solids. But in case we exclude that one, between ionic and the molecules, ionic because we have permanent dipole, cation, anion, positive and negative, it should have a stronger IMF, higher melting point, molecules, non-polar, so, or we have only non-metals, lower melting point. So that is why we may have this statement for atomic solid. Atomic solids can be classified by another forms, but this is not the one part of our class. But if in case we are going to say, why do we have a variety of melting point for atomic solids, we are going to talk about this slide. Atomic solids can be classified again based on covalent, non-bonding, and metallic solid. Solids in metals like gold again, and for non-bonding atomic solids, so we may have the noble gases, and they are not going to bond by each other. They are not going to make any bonds. They are going to be attracted by the another same atoms. We call that dispersion force. So we expect to have very low melting point. And covalent atomic solid, whenever we have metalloids like silicon. So there are some classification for atomic solid as well. This is the story of chapter 12. Thank you for watching.